classes, right? So it's class 6 or class 7 or class 8. Or can we predict perhaps also a value somewhere in between 7 or 8? And that we can do with regression. That's also a subject in week 4. And then after that, we're going to take it along with unsupervised learning with the clustering. And in 6, we're going to do the neural networks and some advanced neural networks and so on. That will come later. Again, in data science, the most important job is to get the data and find the data and explore it. That's where we're going to start also with the exercise. Later on, after the exercises, we can have a discussion about the different group topics. I have received, I guess, 2 proposals. I haven't read them yet. I got one yesterday evening. I haven't checked that one out yet. You guys had another question, right?
So we send our
Yeah.
Eric sent one and Wade sent one.
Yes. Those 2. But I haven't read them yet. Did you, Bart? Perhaps?
No, not really.
No, we haven't had time yet to read. But we can discuss it for today. Okay, so where are we? Again, here in week 2, doing the practice work. So let's see what we can do. On the agenda, again, web scraping, but also the wine data set. And I'd like to discuss the group assignments. Right. Okay, let's start with the web scraping. How did that go? Did everybody try to do it? Yeah? Did you get some good results?
I think so.
Yeah? Did it work?
The only director I couldn't click it, so maybe it gave me like no, like twice.
Okay.
Still gave me the same thing.
Possible perhaps to have a look at your data? Can you share the screen?
Yeah, of course.
If you go into Teams.
Yeah.
So if you go into Teams, share your screen.
Yeah. Is it on conference? Usually?
It's on Canvas. Yeah, on the first page. The link. That one. Yeah.
Okay. Automatisch. Oh, you have to switch off your microphone, else you get the signal right. Yeah, that's your work.
Yeah, we also
So luckily you have automatic equipment that.
Yeah.
This is the one. Yeah.
Yeah.
Okay.
That's great.
You did.
But the only thing that didn't work was the director one. And I tried to click it on multiple ways.
Right.
I don't know if I maybe selected.
Okay. But I notice here that you only have one name here for the stars, right?
Yeah. Yeah, but it has.
Only the first one?
No. The movie is just named like 8 times.
Oh, right. Okay.
Yeah.
Now I see it.
That's because you select multiple of it. You don't have to do it there. Then it will place it in one cell.
Yeah, depends on how you set up the scraper. Anybody that would like to share it, or shall I share it?
Oh,
Yeah?
Yeah.
Thank you. Yeah? Maybe you can share it. Let's have a look.
So if you don't want 3 microbases, you have to do single instead of multiple.
Well, the first thing is your let's say your basic your starting page is your page which does 250 movies, right?
Yeah.
So actually those are all links. So what you should do, start with scraping all these links. So you should indicate them and then say multiple with a a mark, and then it will scrape all these links, and behind these links, you come to the specific page for a movie, and on that page it's easiest to select all of your writers, all of your directors, all of your stars, and so on, in one go.
Right.
So and then you'll get a scraping result with all your stars here in this one cell.
Oh, but he also has 3 Michael Bays.
Yeah, so, well,
Categories and
then in that case you
subcategories.
should take
Open
them out
developer
later on.
tools.
So
Navigation
remember,
with categories
keep the
and
scraping
subcategories.
as simple as possible.
Each
And then
subcategory has a
afterwards,
list of
in Python,
products
you can
that lead to product pages.
recompile or change the data
In this
much
tutorial,
quicker
I
than
will
you
show
can
how
in
to
the
make a
web
scraper that scrapes
So
these
make the
products
scraping
by
as easy
navigating
as
through
possible.
all of the categories and subcategories.
So
To open Web Scraper's toolbar, open Developer Tools.
I'll show
You can
it,
find
but
Web
let's say
Scraper
here,
tab.
Maybe you can show it.
I'll start by creating a new sitemap. Let's call this sitemap e-commerce. The start URL will be the landing page of this site. Web Scraper will start scraping from this URL, and then it will navigate
Can
the
you
rest of the
Brian,
site.
or
No.
Now I am
Shall I
going to
show it?
build multiple
Yeah?
selectors that will be arranged in
Okay,
a tree-like
let me show
structure,
it.
similarly how
So-
the site is built. These selectors will define how the site will be navigated and how the data is going to be extracted.
So here you have your
To visit
website,
these
right? So
categories, I'm
I
going to
go
create
to
a
the
link
top
selector.
50 sites. So this is your
The
starting
selector will be
page,
called
right?
category link,
So let me,
and I will change its type
Put it here.
to link.
so here you
Now I
have
can
the
select
web
the
scraper
category
in
link
the
elements from the
bottom.
page by
Let's
clicking
let's see,
Select
IMDb 250. Yeah. So what you should do is
I'm also checking the multiple checkbox
first
because multiple
select
links
these
will be
links
found
over
on this
here.
page.
I can show the
The
graph
selector is now
perhaps.
ready.
Here you have a
To
graph,
validate the
selector
selector,
graph.
I click Data
Then you
Preview
can
to see
see
if it
how these
works.
selectors work. I don't know if you can see it in the back.
Now
but
let's go to one of the
start
category
with your
pages
root
to create a
page.
subcategory link selector.
Initially, you should show the link itself,
Also,
right?
I am clicking
Yeah.
on the category selector
not
so
for
that the
movie
subcategory
itself.
selector is executed
Yeah,
in
so
category
first
page.
from this root page, that's the root
Similarly,
page.
like the category link selector,
You select
I will
these
create
links,
a
multiple
subcategory
links,
selector.
and indicate that they are type link. And then in the specific page behind this link, then you can select the selectors for the different data that you would like to have.
Lars, if you can share your screen.
Oh,
And I am
Okay.
also checking the selector with Data Preview.
sure.
I can move forward to the subcategory page. Here, I will create a
Sure.
link selector that will navigate to product pages.
Now it should be fine. Okay. So if I look here at this selector, I can here.
At this point, the selectors
example,
are
I do edit
configured
here.
to navigate from
So,
Start URL
In this
product
page,
pages
you
in all
indicate
categories.
a link. So
Under the product link selector,
select
I
all
will
these
add
links.
multiple
You
data
say, okay,
extraction
multiple.
selectors to
So
extract
it will
data
take
from
all
a
these
product
links.
page.
And then
I'll start by creating a text
if you've
selector
done
that
that,
will extract the name of this
then you
product.
can here double click here at the film link, and then
Similarly,
and then you
I'll
can
add text
start
selectors
making
to
these
extract
other
price and
selectors like
description.
this. So you go, for example, here. I'll select a page here, like this one. And what we wanted to have is here the director, the writers, and the stars, right? So, for example, if you take the stars,
To extract the image URL,
if I want
I'll
to,
create
let's
an
say
image
I
selector.
make a new selector here.
As you can see, there are
Say the
different
stars,
types of
I'll do it
selectors
again.
to extract specific data types.
That's of type text because we want to take the text, right? And then we need to select the right.
Now I have all
And
the
you
product
see, if I
information
move
selectors
over,
that I
if
want.
I hover over
I can
here,
quickly
I
check
only
them with
select
Data
one
Preview.
name. If you want them all, you can go a little bit up, right?
Also,
So
you should go
it's-
to other product
it's
pages
very
to
precise.
check whether the selectors
You can
work
also
as
take
expected
this
there.
one, I guess, the whole thing.
After creating selectors, you can open Selector Graph
So
to get an overview
be careful
of how
where
the
to
sitemap
put your
is
mouse
built.
and on what to select, because it's all, let's say, HTML indented. So you can
Here
zoom
you can
out
see how the
the
scraper
way you
will
would like
navigate to
to
product
do it.
page.
And
all
the
of the
easiest
link
way is to
selectors.
select all these names.
The sitemap is
And
now
again, make
complete.
the scraping as
and I can launch
simple
the
as
scraper
possible. And
locally.
then afterwards, when you've
I'll
selected
open the
your
scrape view and
data,
click Start Scraping
then
button.
it's easier to separate these names out, for example.
As you can see,
Because
Web
if
Scraper launched
I don't
a
know,
pop-up
did
window
anybody
in which it is loading URLs
manage to do it
extract
like
data.
this? And
While the
get
data is being
more
scraped,
multiple names
you
in
can
one
click the
cell?
refresh button to check that everything is working as
Yeah?
expected. I'll pause the video while the scraper is
Yeah,
running.
you did like this as well?
The scraper window is
Right.
now closed,
I
and
managed
here
to
you can see
do
all of
driving,
the
but
scraped
not do this
data.
part, I don't know.
To export the data,
Okay,
I'm going to
okay.
open Export
Well,
Data View.
anyway, if
where a
I
download
can
link will
here
appear.
scrape a little bit and see what it will give. So here I start scraping on the page, and then
And here you can see
automatically
the scraped data.
go to the different pages, right?
If you want to learn more
And then
about
let's look
WebScraper, go to
what Scraper has found.
webscraper.io.
So I can
There
refresh
you
here
will
in the
find more
bottom.
video tutorials
And
and
then here we
documentation
see
about all of the selector types.
Dances Blue Wolf. You saw the page already. And then here you can see with writers and also stars, I get here one cell with all the names here, right? So that's the easiest way to do it. But then again, then you have a problem because this is formatted in a very specific way, because the first name and the last name starts with a capital, and then there's no, let's say, separation character here in between. It immediately starts with the second name, as you can see over here. So now you need to write some code in Python, perhaps to separate these out and put a comma in between. To make it easier.
Can we also make a branch in this graph?
Yeah, you can do as well, but then you have to select multiple, but it will take more time again. It's probably easier to do it in Python afterwards.
So also we can do all the process of scrapping directly in Python, yeah?
That's also a possibility.
So why we do
I think in week 1 I told you about different alternatives for scraping. This is the easiest way with web scraping. If that is not successful or it doesn't work, sometimes these sites have problems. Site owners do not really like that you're scraping their site. So that's why we put in some time here before the next page starts scraping, right? But you can do it in Python yourself, for example, with the Scrapy library. But it takes some time to dive in and to see how it works. A more simple library is Beautiful Soup. Let's say then you have to have some HTML knowledge, because you need.
that way we can directly address the data or cell we want.
Right,
We do not need to sort anything.
that's correct. But it takes some time to study Beautiful Soup and know, okay, what kind of class or IDs do I need to look at in the HTML code and so on. It's possible. And for those, I think one of you mentioned web development, right? Who was the one with some
I think
web?
that's Lars.
The only online.
Online. Okay, Lars, you had some HTML experience. You might want to work with Beautiful Soup in this case. That's a possibility. That's an alternative. But again, if you most of the things that you guys need to do, you can do with web scraping. So that's the easiest thing. And remember, make it as simple as possible, and do the, let's say, the data changing afterwards in Python. And I'll show you how to change that text over there into a list separated, let's say, cell for taking out those names, for example, right? So let's have a look here. Then I'll move over to, let me see, yeah, to Colab. Yeah, if I get this, yeah. Here we go to Colab. Okay, I'll make this a little bit bigger so you all can you read this in the back? Yeah? Okay, so what I can do, I scraped these 250 movies, and I get, for example, the writers' names and the star names all in one cell, right? So I've put that file, I exported that one and put it on Drive so I can read it with pandas and put it into a data frame. So that's what I'm going to do here. So in order to do so, I need to import pandas, obviously first. I need to connect to my Google Drive again, right? Because I put my file the scraped file into the Google Drive. So let's do it. It's already mounted, that's fine. And then with this command here, read CSV, I read this file, I called it imdb250.csv, I read it from my drive, okay? And this, with this command, the next one, I can look at the top 5 rows of this data frame. Yeah, I call this data frame IMDb top 250. Let's execute it. And here we have it. So this is my web scrape file now into a data frame in Pandas, right? And as I can see over here, again, I have my riders and stars here. By the way, I need to maybe get rid of this one, screenplay by. But here again, I see this very strange thing that they've concatenated all these names together here. So I want to separate those out. Okay, how to do that? Let's take a look at it. Hey, good morning. So let's separate it out. Let's see how that could work, because there are multiple ways to do it. So we need to separate that out. We need some code to do it. What I can recommend code-wise in Python is to make a function that will do that. So you make a function, you do that with def, and you give that function a name, for example, separate the names. And this function will have one input, and that is the, let's say, the value of all these names together in this strange format, right? And your output of this function here, the return, is the new names, but then separated out with commas, right? So that is what the function will do. So I recommend, if you have a certain, let's say, task to be performed, make a function out of it. So this is a function to do it, and as you can see over here, what this function does is to walk through the text, let's say character by character, and then deciding what to do. Yeah, so we have this strange format where do we have an example here? So let's take a look again at this example. Here. So I get this. Yeah. What I want to do is to change this string. This is text, right? I want to change it, and I would like to get rid of this word. But then you have Jim Carrey over here. So I want to put a comma here in between. So what I can do, there's one alternative, is to walk through by character through this text. Yeah. And as soon as I see a uppercase character, I decide what to do. For example, if I see an uppercase character and there's a space just before it, I do nothing. I just add the same character to a new string. If I see a uppercase character and there's not a space before it, then I first put in a comma and then put a character in a new string. So that's the way, that's one of the ways that I can change this string around, right? Well, how would that look like? And this is in text. I hope you can read it. It's a for loop. The for loop walks through your characters one by one. And here you take the length of your input, your input text. You walk through it, and then you say, okay, if the character is an uppercase character, then if it's not the first character, and if there's not a space before it, like I just said, then I just add this character to a new string, okay? But if there is if there's not a space before it, then I put in this comma, this separate comma, and then add the character, okay? So I build up the new string in this case, and I output it here with a return, okay? So that's one way of doing this manipulation of strings in Python. The other way, well, I can again try to run it here before I go to the other way. I can hear it. For example, I have this text here as an example, this same text. and I can try to run this function, and that's what I do here. So here I call this function, and I put in this text here, and then see what comes out of it. So this is my original text. Here I have my comma separated names. Yep. And also can put them in a list by splitting it by comma. And then I put them in a list like this. Also a possibility. Okay? So that's one way of doing it, for manipulating this text, this string. The other way is much faster but more complex. It's something called regional expressions. And that's, can be quite strong. And in this case, I look for a certain pattern. I look for this pattern. First name, last name, with a space in between. If I see it, then I put that as a separate string, and I recompile it. So with just 2 lines of code here, I can separate out this same text with just 2 lines of code. So it's very strong. Regular expressions.
Yes,
Regular expressions.
Yeah,
I said regional.
Yeah, it's
Regular expressions. So with regular expressions, it can be quite strong in manipulating string. That's the other alternative. And let's try it out here. And I can run it. Here again, I have my input text as an example, and I put them in this function, put this file into it, and I get this back from the function. Okay? So that's also a possibility, but a little bit more complex, but very strong. Okay. And then let's suppose that you wanna do some data science with this file. For example, you want to try to predict what kind of rating a certain movie will get. Yeah? So what I then need to do is to convert all of these codes into the whole data frame with all these 250 movies. I need to, let's say, recompile all of those 250 stars, right? And that's what I've done here. So what you can do with pandas is to apply a certain function to every cell in a certain column. And that's what you see here. So first I copy this the whole data frame, just in case. So I have a new data frame, and it's a copy of the imported one. And what I do, I only look at the column stars. This is the way that you select a certain column from a data frame with these square brackets, right, with the name of the column. And that will be converted, or this function, separate names, which I defined, I can apply it to each cell. So with just this one command, I change all these cells with this function, separate names. Okay? So I can try to run it, and then we can see. So I print here the first 5 lines only from this column. Here you have the original text, and here you have the new one, right? So it will nicely, for all these 250 movies, it will change these strings. Okay? So again, the scraping should be as simple as possible, and then do your calculations or string manipulations afterwards. That's much easier and quicker, because otherwise it will take too much time to find out, to get the right data. It's better to get more data from your scraping and then filtering it out than try to do everything in the scraping itself, right? Okay, another question, yeah?
So I did it, so that every line has a new star, right?
Right.
Couldn't you just say, if the movie name is the same, then combine these names into one cell?
Yeah, well that brings me to another question, and it is, if you want to, let's say, predict the rating of a movie, then if you have, let's say, multiple stars into one cell, that's possible in a data frame. A data frame can contain lists in a certain cell, right? But that will be difficult. That's not in that format you will not be able to do some machine learning with it, really. So you should think of another way of, let's say, manipulating the file, because machine learning cannot really handle lists in cells in data frames. So what you probably want to do, for example, is if you want to predict the rating of a movie, then you probably first want to manipulate the stars and say, okay, let's try to scrape all the stars that there are in these movies, and let's give each star a certain rating, and then find out, okay, what is the star with the highest rating in this movie, and then put that rating into this cell. So you get the star with the highest rating for your movie. So that might be a possibility to change it around in your thinking and allow you to do the machine learning on this file. So then you have translated, let's say, the stars into, okay, what is the value? Can you give a value for these stars? And put that in your, let's say, a final file for machine learning. So that's also a process that needs some time to find out, okay, how to do it and what the best approach is in your situation. Yeah, because what we want in machine learning is to have the file and the number of features, the number of columns, as small as possible. The more features we have, the more difficult it will be for the machine learning algorithms to find out patterns. So we want a lot of rows. We want as much as possible data in terms of rows, but not in terms of features, right? And if we can replace certain features and taking them from other data and giving them certain values and put them in, then we make it easy, like with the stars. And translating that first to, let's say, the star or the two or the top three stars with the highest rating and put those into your file, right? Okay. So far about the web scraping. Then I think we're going to move to the wine data set. Let me have a look. So again, I have this code also here. It's on Colab. I put it already on Canvas, and you will find it in the slides as well as an example of how to do it. Okay. Okay, then the wine data set. Again, we're going to use this data set for the coming lectures also to see, okay, how does it perform with the different algorithms and can we find some patterns into it. The first thing always to do is to have a closer look at the data, and that was the exercise.
Yeah, exactly. Yeah. They have to play around with it.
Yeah, so this was the data set, the red wine data set with 12 features with a label. The label, so the quality is the label. We call that the label, so it's supervised learning. So here you'll find values between, I think, 3 and 8 or something like that. And there are a lot of chemical type of features here in this file. And what we want to look at is, okay, can we find some sort of a connection between certain chemical values and the quality of the wine? And in order to do so, we start first by looking at the data. Then?
I tried to mount my drive,
Yeah.
but it didn't work.
Didn't?
I tried, it says content drive in your case.
Right.
I found another way, but I would like it to work.
Yeah.
I'm not sure. I tried.
We can maybe take a look at that later in the lecture.
Yeah.
We have some time. And then did you copy the exact code as I showed you here?
I changed it to my directory.
Yeah.
But it didn't work.
Okay, probably
And
something
it did
wrong.
mount, but then
Yeah, okay, then there's something wrong in your path, I guess. The file path. So your file path is probably not correct. Did you put your file in a certain subdirectory or?
Yeah.
You did? Okay, let's check it. We'll do it later. We'll look at it later in this lecture. So this is the thing to do. Look at the data, We want to know, okay, how big is it? How many features? How many rows? What are the distribution of the different values and so on and so on? And also make some nice graphical representation of the data. And we can maybe, from those graphical overviews, already conclude some things about this data, right? Okay. So, is there anybody that would like to share? Did you all succeed? First question.
I have 2 questions.
You didn't do it with the Colab?
Okay. Well, I found another way.
Okay.
But,
Work around.
there was a question. Any other visual overviews that might be relevant, such as geographical data?
Yeah.
But there is not.
Not
That's not in the data set. So
Not in
it's
this
like,
case.
impossible.
Not really here, no.
So
But if you
I was
take
thinking,
it-
like, why is it in the exercise?
Because this is more a general list. It's a general checklist.
Oh,
Not only specific for this, but you should check it. So
okay.
if your conclusion is right, there is no geographical data in it. That's a good conclusion. But sometimes you have, okay, where is this from, which region in Portugal does this wine come from? Or what country, or what province, or what city, or whatever, but it's not in this one.
And it's mentioned as an example, any other visual overviews that might be relevant.
Might be relevant.
Okay.
Yeah, so it's also
okay,
reading
fair
the,
enough.
yeah.
And I didn't understand what HOML means.
It's the book.
Hands-on machinery. We have 4 books, and 4 letter abbreviations of them. And HOML means hands-on machinery.
Okay.
What I can really recommend for all of you guys, again, I've said it many times, is to look at the first two, how do you call it? Chapters, right. The first 2 chapters.
It's really nice, it's really easy reading.
Because that will give you.
Look through it. They have a lot of
Yeah.
exercises.
Yeah, they have exercise, it's really nice.
Yeah. So that will give you a good grasp of okay, what to expect more or less. It's
And they have
especially
also
chapter
an
2.
online environment, right?
Yeah.
Where they have like the last updated code and all that stuff. So it's
there's
really
a
a nice
Yeah.
thing.
So there's a Git environment for all of the source code and so on as well. I really can recommend it. Do it.
Yeah.
Because it will help you.
And I think, is it also in the library here or not?
Don't think so. But for the good looking Google practices, you will find it, right? You could find it. It's no secret. Okay, good. Anybody that would like to share something?
Yeah, but you did get something, right?
Yeah, I literally followed exactly what.
Okay, show.
Okay, can you share?
Yeah. HOML. It's like
HOML.
HTML where you really can.
Okay. Did you share your screen? Yep, there we go. Can you enlarge it a little bit, the code? Zooming in. A little bit zooming, is it possible?
Oh, you just upload it each time when you run the code or not?
Sorry?
You upload the file each time you run the code.
No, I didn't.
No, but with the uploaded files upload.
No, I asked Chat GPT what another way was besides.
Told you that's also possible.
Yeah.
And yeah, well, this is what I got, and yeah, so.
Okay, can you take us through? So you start with importing, right? That's correct. Okay.
Yeah, and then I got to choose a file. I chose obviously this one.
Yeah.
And then.
That's your data.
The data frame is called wine_df in your case, right?
Yeah.
Okay.
So
good.
This one means I can make a data frame
Right.
of it, and this is the data frame.
Yeah. if you just put in the name of the data frame, it will take your first 5 rows and the last 5 rows, right? So that's why you see these dots over here. Yeah. Okay.
And then
So-
describe it.
So what you can see, if you go up a little, so that's already important information to start with here.
Yeah.
Okay.
One of the questions.
So we have almost 1,600 different wines here, and we have, for each wine we have 12 features, right? Okay.
And I actually, it's also over there, but then some more info
Yeah.
about the different features.
Right.
And again, rows and columns.
Yeah. If you go up a little,
More.
yeah, you got for each. You see the values here for each of the different features. Okay. Yeah. Can go up, go down. Sorry.
And then I asked the chat again how to see if there are missing values, and it came up with this. So, well,
Yeah.
there are no missing values, as you can see.
Yeah, here is the isNull method, which means from the data frame, it will select the rows which have none or 0 values, right?
The non
I think ChatGPT is nice, but do you also understand what's happening?
Yeah, but
Okay.
it's way faster.
Yeah,
I
no,
look
it's
up
fine. I
on
understand.
Google, it gives me is null, and then I have to type it, and then I can just copy paste this.
Right.
Yeah.
It's way faster.
No, I understand.
Okay, and then, all right, so no missing
Future
values,
programming.
so that's important. I didn't talk so much about missing values last time, but there are different techniques how to handle missing values. Depends on what kind of values are missing. You might also, for your group, you might enter data that has some missing values. And then you can decide, okay, if there are just a few, well, then it's probably better to delete these rows. But if there are more, okay, what to do? One possibility is to replace them with the mean for the column, where you have the value, or do a regression on the column to see, okay, that you can somehow predict what the value could be, or you could set the value to 0. Depending on, look at the slides from the beginning of this week, I have some tips on how to handle missing values if you encounter some, okay? In this case, there are no missing values, so that's easy.
Yeah.
Yeah? Okay, and then we go to some statistics.
Yeah.
You do like this, but there's an easier way. But okay, you do it with NumPy, right? And you calculate standard deviations
Yeah, so,
and means, percentiles, for example.
and then I got, well,
Right.
standard deviation for each feature,
Yeah,
then the mean for each feature below that,
right.
and then, oh yeah, the percentiles yeah,
Where do you have the percentiles?
it's one,
Here.
one row.
Okay, and that is average for. Is that for which feature is this? These percentiles?
Yeah, I'm not sure. I think it didn't pick.
Probably from the whole data set. And
Yeah,
not-
I think so too.
Right. Let me quickly show you a simpler way to do this. Statistical things. Let me see. Where do we have it? Yeah, here. Okay. I'll do this as well. Let me see. This is what you got. Show info. This is what you showed as well, right? This, by the way, might be of interest. but I'll skip that one for a while. I'll go to this one. Here, the describe command, this one. So your data frame and then describe.
Yeah.
That'll give you all of your statistical information. So if I'll do that, you get this. And then for each feature, you get your mean value, you get your standard deviation, so how spread is your value, right? You get your minimum value somewhere in the column, you get your maximum value, and you get your percentiles. And percentiles means, okay, 25% of all values are below 7.1. 50% of the values are below 7.9. And 75% of your values are below 9.2.
Box plot lines, right?
Yeah, the quartiles, so-called quartiles. Yeah, and that can be handy, but obviously this is data. Let's say these are just numbers. We'd like to see some graphs as well. That will make things much more clear. But we'll come to that, I guess, right?
Yeah. Well, I followed exactly. But,
So again, the describe command is the one to use for all these, instead of going to NumPy and doing all these separate calculations. It's already in here. It gives you some idea on the distribution of the data. Okay? So let's go back. Okay. So you have your statistical information here, right?
Yeah.
Histograms. Okay.
Instagram of
right.
I have to zoom out a little bit.
Yeah. So this is one of your the histogram from one of your features, volatile acidity.
Yeah.
Yeah. And you specify the number of bins, so that means, okay, in how many bins should the data be distributed? And then for each bin it will calculate it, the amount, right?
Right.
Okay.
174. We want to
But
try
it
to
also
do
will
better.
take some
and
time
that-
because you will have to do it for
and then
all
we
of
traverse
your
down one last time, adding the last
features.
zero,
This is
giving
just
us the
one. Did you do
code
it for all of them?
000 for the column. We have a total bits used tree has a value of 0.
Okay.
And add it to the tree. E3, and I connect the root blanked out. So let's fill those in.
I think
So if I want to find out what the code for A is, I traverse down the right branch.
Okay.
once.
I'll show you the
traverse down right
quick
branch
way to do it
and I
again.
do one
Also
left
in
node
pandas
traversal.
plotting.
So my code is 1,
And
1,
then it's
0.
over here.
The code length
Show
is 3
histograms per
times the
feature.
frequency,
So
which is
we're
10,
gonna
giving us
CI
a total bit value
command.
of 30.
Polynomial
And then
time
just plotting.
algorithm.
Now when I want to do the character code for each,
Next,
So if
we'll
you do
pick
I
that,
traverse
4.
down a right branch.
you will get this.
Yeah, I had the problem that all the plots were below each other.
Everyone is buzzing about honeycomb pasta right now,
Okay.
so today I'm gonna show you how to make it. But first,
Now this one will
let me boil
separate them
some
out
water.
like this.
Hello friends,
so
to Kitsugi. Of course,
that
for
this is the
every
default
iterative
setup.
is given in just
So if
3
you run the
steps.
same command, the hist
Optimal.
command, and then
So
plot it,
at
you will get
each
this.
stage, we
Yeah.
select a locally optimal value with the hope of getting
Sorry?
to the best find a path ending at a leaf node and having sum of nodes as maximum.
Yeah, how do you mean how we can change
So
it?
let's start
What
from our
did you want to change?
node 11. We conclude that make
Okay, that
locally
means
optimal
going
PV
into
choices
matplotlib and then
don't
defining
always give us
number
a
of,
globally optimal value.
subplots because it's
So
these are all
when are we
subplots.
supposed to use 3D methods?
In this case, I just wanted
All
to
problems
keep it
which are
simple
generally solved using
and
Unreal
just
Engine
use this one.
satisfy
But then you
two
should here put
properties.
in a few commands
3D
here.
choice
I don't know
property,
now from the top of
that
my
is
head, but
making the best
a
choice
number of
at a
extra
moment,
lines to
leading to a
define
global optimum.
how these subplots should be plotted.
Next property
But
is
that's
the
possible, of
optimal
course.
substructure.
This is just the default
Problems
setup.
whose
make
optimal
it easy.
solution can be constructed
Yeah.
efficiently from
So okay,
optimal
Finn, you did your
solutions
histograms.
to
What?
subproblems.
Any conclusions
This
already
property
from these
may look similar
histograms?
to one in dynamic programming. However, one thing to note here is that greedy algorithm never reconsiders its sources.
Any conclusions?
This is the main difference from dynamic programming. which is
the
exhaustive
quality, there's
and is
a lot
guaranteed
of
to find a
fives,
solution.
Yeah.
so a lot of bad wine.
Finally, we look at
I would
some
say.
application which
Right.
uses greedy algorithms.
So this is a nice one because this was your
Activity selection
label.
problem
This is the thing to
Huffman coding.
predict. Yeah.
Job sequencing
So
problem,
here you can see in your
functional
data
knapsack
set
problem,
that you're going to
Prim,
use.
minimum
See how the
spanning tree
distribution is on the
are few
different
of
qualities
such
of wines.
applications.
And here you can see that there are just a
With this,
few
we wrap
good
up this
wines.
tutorial.
Yeah.
If you have any doubts or
So what does
suggestions,
this tell you
please leave them in the
about the
comment
data
section
set?
below. Thanks for
Would
watching.
is this good? Is this bad?
Hello friends and welcome to
Reality, right?
Sorry?
the
It's kind of
path
the reality
ending
that
at a
is.
leaf node and
Well,
having
That depends.
sum of
That's
nodes
something
as
that we do not
maximum.
know.
So let's
Show you a
start
picture of the
from our
planes
root
returning
node.
from the Second World War
The sum at start
with all
is
these
3,
bullet holes, right? And then
There
the
are two
conclusions
possible
about,
paths,
okay, let's
4
reinforce
and 7.
at those locations
However,
where we have
here
those
we
bullet
make a
holes. But
greedy
then,
choice
okay, there was a lot of
and
missing
choose
data
the
because
one that is maximum.
there are a lot of
That
planes
is
that didn't
7.
return. They had the bullet holes in other
Our
places.
total now
So
is
this
10.
is similar. We do
Now,
not know really
Once at 7,
if we have
to
if
choose
this is a good
between
distribution of the
9
reality.
and 11.
So that's
A
the problem
greedy
here.
choice
We have
would be to
1600
select
wines,
the larger of the
which
two.
sounds quite a lot,
We
by the
select
way,
11
for a small
and end up
region.
having a path
certain
with sum
quantities
as
wines.
21.
But
Can we
maybe
do
we need
better
some
than
more
this?
information if
Yes,
this is a
we
good
have a
distribution
path.
or not.
If
In
we
general,
start from
from
3,
data science point of view, it would
go
be
to
best
4,
to have
and then to 20.
larger amounts
This
for
path
each of these
would
qualities.
give us a
Because if
sum
we
of
want to
27,
predict the
which
quality,
is greater than the
then the more
one achieved
examples we
through
have
greedy
of
method.
certain quality, the better it is.
So here we
So
can
it will
clearly
kind of
that
be kind of
making
hard perhaps
locally
to
optimal greedy
predict an
choices
8
don't
because
always
we have
give
so
us a
little
globally
wines that
optimal
actually
value.
are 8.
So
So it will
when
be
are we
harder to
supposed to
separate
use
them out.
greedy methods?
Yeah.
All problems which are generally solved
Okay,
using
but
greedy
again,
algorithm
we see here some
satisfy
things like,
two
for example,
properties.
total sulfur
The greedy
dioxide,
choice property,
a lot
that
of
is
values
making
in
the
this
best
area.
choice
So
at
most
the
of the
moment,
wines, they have
leading to
a
a global
lower
optimum.
total sulfur dioxide.
Next property is the
So
optimal
here you can
substructure.
see how the
Problems
distribution
whose
is,
optimal solution can
and
be constructed
the more
efficiently from optimal
distributed it
solution
is,
of its
the easier it will
sub-problems.
be for the machine learning
This
to make a
property
distinction.
may look similar to one
Because
in
if all
dynamic
the
programming.
wines for a certain feature are
However,
almost the
one
same
thing to
value,
note here is
then
that
it is
greedy
very hard
algorithm
for this
never
value
reconsiders
to
its
kind of
choices.
predict the quality.
This
right?
is the main difference
So
from
I'll
dynamic
come back to you.
programming, which
So
is
if we
exhaustive
look over
and is
here,
guaranteed to find a solution.
here the chlorides.
Finally, we look at some application which uses
Okay, this is an
greedy
interesting one. We
algorithms.
see
Activity
some
selection
wines over
problem,
here,
Huffman
very high in
coding,
the chlorides.
job
It would be kind
sequencing
of interesting
problem,
to see, okay, what does it
functional
mean
knapsack
to the
problem,
quality?
Prim,
So,
minimum
okay, I
spanning
want to
tree
zoom in
are
here
few
because we
of
see a lot
such
of wines here,
applications.
but we also see some wines over here. So
With
it
this,
might be
we wrap
interesting,
up this tutorial.
and
If
that's
you
why
have
these
any
pictures
doubts
are
or
interesting,
suggestions,
to zoom
please
in
leave
on
them
this
in the
one and
comment
say,
section
okay,
below.
but do
Thanks
we
for
see
watching.
here how the qualities are distributed? We're going to look at this later on. Perhaps you already have it. Okay. Maybe we continue with your one.
I didn't look at the small ones.
You did not? Okay.
Well, not yet. No.
Not yet. Did you do a pair plot?
I literally did exactly what was in the exercise.
Oh, okay, okay.
Uh,
Okay, so a histogram for each column, yeah? Okay. And then
the correlation.
the correlation matrix. What does this say? We see a lot of numbers. We see all the features here in the matrix. We have a lot of numbers here.
Yeah, well, you have to look at one side or the other, right? It's mirrored.
It's a mirror. It's mirrored over the diagonal,
Yeah.
right?
But
And obviously the diagonal is all one because it's optimal correlated with each other, of course.
and I found or I wrote down the variable names or the two variable names.
My name is Ella. I'm used to just learning math head down and watch a lot of YouTube. Brilliant is different.
And then
I like decision trees.
Yeah.
How about you?
and then maybe scatterplot
Same.
of all those.
Right.
So numeric thresholds can be
Okay.
different.
Before we do that, if you go back to this correlation matrix,
And when a
is
decision
this
tree
principle,
predicts
because this is an
numeric
important
values,
principle of this correlation. That's
pretend you've never
clear
seen this
for
tree
everyone how
before.
that works.
And let's see
Because
how to build a tree
what you see
starting
over
with
here is
just
the R
data.
value.
The first thing we do
And the
is
R
decide
values is
whether
something
loves
about
popcorn,
the-
loves soda,
let's
or
say the
age
strength
should
of
be
the
the
correlation
question we
between
ask
two
at the very top of the
variables.
tree.
Okay, in this R
To
value,
make that
this can
decision,
be
we'll
between
start by looking at
either
how well
1
loves
or minus
popcorn
1.
predicts whether or not someone
So I think
loves
it's important
cool
for
as
everybody to
ice.
understand what
To do
this R
this,
value
we'll
really
make a
means.
super
Just as an
simple
example,
tree that only asks
you have,
if
for
someone
example,
loves
make
popcorn,
let's say,
and then
put
we'll
up a
run the
graph,
data down the tree.
and let's say that
For
I
example,
think I used
the
this
first
example
the
before.
tree
Here on the
does a better
x-axis,
job
we're going to
predicting
have,
who will and who will not
the cylinder
leaves.
capacity of a car.
The
or
Gini
a
impurity
motor of a
for the
car,
leaf on the
right?
left
So let's
is
say we have the motor
squared,
CC,
represent
number
the
of
same
CCs.
number of people.
Yeah.
405.
And here we have the max speed.
Likewise,
of
the
the
Gini
car.
impurity for loves everyone with 4 are tied for the
So if we're
lowest
now going to
because two
have a lot
of
of cars,
because there is
and we're
no
going
reason
to
to
look at their
the output
cylinder
value
capacity,
is
we're going to look
loves
at their
cool as
maximum speed.
ice.
and we make a scatter plot out of it,
To split
Yeah.
this node into leaves
then probably
is also a
we
leaf
would get something like
because
this.
there is no reason to continue splitting these people into smaller groups.
Agree?
Now there is just one last
So we
thing
could
we need to
draw a
do before
line,
we are done
call it a
building this
regression
tree.
line, a linear line here,
We need to assign output
between,
values for each leaf.
indicating that if the
Generally
cylinder
speaking,
capacity
the
increases,
output of a leaf is whatever
then the
category that
maximum
has
speed
the
of the
most
car will increase as
values.
well, right?
In other words, because the majority of the people
Well,
in these
the way
leaves
that
do
these
not love
values are
cool as
distributed
ice,
will
the
say
output
something
values
about the
are
R value,
does not love cool as ice.
So
And
if
because
all
the
these
majority
spots
of the
would
people in this leaf love
perfectly
cool as
be on
ice,
this line,
the
so I
output
wouldn't
value
have
is
any
loves cool as ice.
diversions
Hooray!
here.
We finished
all
building
my
a tree from
values
this data.
would be perfectly
Double
on this line.
bam! Now,
would be the
if
R
someone new
value?
comes along and we want to predict if they
Exactly
will
one,
love
right?
cool as ice,
So
then we
have
run
an
the
R of
data
1.
down our tree. And because they love
And
soda,
if we
they
have
go to the
something
left.
like this,
And because they are 15, so age less than
what would be the R
12.5
value
is
in
false.
this case? Approximately. 0.5? A little higher, I would say, 0.7, 0.8. And if all these points will be cluttered around here, like this, what would be your R value? 0, right? When would your R value be minus 1?
It's on the right down.
Top down. Can you give any example when this would be the case? A practical example.
Death by collision and speed.
Right?
No,
That's one.
No, that's goes up. Oh, sorry.
That goes up.
Yeah.
Let's say price
Yes, cycle of collision.
price of a car and the age of a car. So let's look at second-hand cars. Yeah. So if the age of the car is just one, let's say 1 year, price would be here. If you have an older car, prices would go down like this. Probably you will get something like this. Something like this, okay? So you could draw, make it linear and do like this. If all these cars would exactly be on this line, we would have an R of -1, okay? So if you look at this correlation matrix, what is interesting to know is, okay, we are trying to predict the quality of the wine. So what is interesting to know is, are there any features here that correlate either perfectly like this or perfectly going up, so either a 1 or a -1 with the quality, because that's a strong indicator. If that is the case, then this feature is optimal correlated with your quality, and that will then be a strong candidate for telling something about the quality of the wine, right? Yes? So what we would typically do here, okay, you have a correlation between every feature in between, but especially interesting is to look at the quality line here. This one or I think it's probably the last one here. Look at the quality line here. And to see, okay, which of these features, if you go up a little, Finn, move it up a little. I want to see here in the bottom. Or down, move it down, sorry.
Oh, down.
Yeah, up here, but down in your... So here's your quality line, right? And here you have your features. So let's look at either values that are close to -1 or values close to +1. And here, in this case, it will be indicated by the color as well. It's kind of hard to see. But yeah, there are some ones that are more important than others.
Well, I only chose alcohol and quality because the other ones are or below 0.5 or -0.5 or 0.5.
Yeah.
Below 0.5.
Yeah. So first candidate is quality here with 0.48, which is, well, reasonable indication, right? So that means it's a plus value, meaning that if the alcohol goes up, the amount of alcohol in these wines, then the quality will become better. Okay? So maybe we should fill it up with more. That will be a good advice for these winemakers. Make the alcohol percentage higher, then maybe the quality of the wine will become better. Okay? So
they sometimes do that.
They do? Yeah.
Because of this point. Yeah.
Or they fill it with motor cooling down liquid. Okay, so that's a good candidate. Another one is maybe this one, volatile acidity. It's -0.39, meaning if the volatile acidity in the wine goes up, quality goes down. So the advice could be to reduce the volatile acidity as much as possible. Not too acid. We don't like too much acid wines, obviously, right? Okay, so this is already a good first indication. Okay.
Is this chart based on exactly linear regression or something else?
It's not specifically linear regression. But I think the R value, that's a Pearson value, and that is, yeah, it is linear. Yeah, Pearson's value implicates linear regression values. That's correct, yeah, I think so, yeah. Because linear would not always be maybe the best solution, obviously. We'll look at that later on when we talk about regression. Because if you have like this for cars, for example, okay, you might draw a line, presuming that you want to approach it with linear regression, but let's say a line like this, like a banana, would make a better fit. But that's the topic of regression. We're going to cover that also. But the R value implies linearity. Yeah. Okay, Finn, if we move down.
Yeah.
Okay, so you made scatter plots of all the different features, right?
Not all. The ones above 0.5 or below -0.5.
Right. Okay, so only the ones that are highly correlated.
Yeah, or semi-high.
Yeah, somewhat.
Somewhat.
Right. Okay. Again, easier way to do this. You're now doing it one by one.
Yeah,
but
it's
yeah, the histogram plot, or the scatter plot rather, because we're talking about scatter plots here. And okay, I have the correlation heat map as well, the same as you have, like this one, right?
But it's also just making meters, right? You're just playing around, and so it's good that you also do sometimes wrong.
Right. So now I know.
Yeah, it's all part of the learning, right? If you just do it first time right, it's not going to stick.
Let me see here the counts.
It's probably 2 lines again, huh?
Histogram for the quality, we had that. Let me check here.
Point scatter, show, done.
That'd be frustrating.
Correlations. Yeah, you were right, Brian. We're talking about the pair plot, yes. That's the easiest way to do it.
Just one line.
Oh, it's
But here you can have like the this one. So this is plotting, pandas plotting, and then you get this. You can do it like this as well. See? Promising correlations like you have, the ones that are really interesting. In this case, quality, alcohol, volatile acidity, and sulfates with the highest R values. And you can have a scatter matrix. And that will look like this. So pair plot, we'll come to that, but scatter matrix is a possibility as well. Here you have your scatter plots, right? The ones you have as well.
Right.
Right. And this is nice. You already then see, okay, how are the wines distributed then? Yeah. Again, here the number of wines for the different qualities. And here we can see already, okay, how are the wines distributed over the different qualities. Did you do a pair plot as well?
No, this is where I
because the pair plot is stronger than this one due to the fact that you can, with your color, you can indicate the label, the quality in this case. So if we do that, we go to this one. That's a Seaborn. The pair plot, quite strong. It will take some time. But if you do so, you get a nice overview with like this, where you have an indication of quality. So light color is 3 and dark is 8 in this case. So we can then here see how the wines are distributed. And I think this one, if you take the first column here, it's about alcohol. That was a strong indicator, we already concluded. And we can see it over here, because here we see how the different qualities are distributed. So light color means high quality, right? So we see here high quality wines with a high probability, right? Is this?
Darker side.
Oh, sorry, darker. It's the other way around. Sorry. So the darker, yeah, that's correct, because there were only a few here. Huh? So here we have the darker wines over here, and there are more wines here with a lower quality. Yeah.
But we said that high alcohol percentage was an indicator for good wine, right?
Yeah.
But now we see high alcohol.
So dark color. Sorry, I turn it around. So dark color is. I said it wrong. Dark color is high quality. So
yeah,
8 has
and the axis to the right is a higher
yeah.
alcohol percentage.
Yeah, you don't see it here, but here you see the alcohol percentage.
And
see?
this is the histogram amount.
Yeah. So this is a nice one. You already have your overview, but also here you can see different features plotted against each other, and that will be more difficult to read, because here, for example, it's quite distributed. And here also, when it comes to volatile acidity, they are quite close to each other, different qualities. And also here, the sulfates.
It's a little bit better.
It's a little bit better.
Yeah.
So probably what you can tell from this data set, it is, well, it's a real data set, so this is the reality, but it will be
quite hard.
Medium hard to predict quality. It's not really strong indicators. We don't see much high R values in this set, right?
I still don't fully get how to read the graphs on the diagonal where the two axes are the same values. For example, here the sulfates against the sulfates.
Yeah.
Against the alcohols.
Yeah, it will print different type of graphs depending for the diagonal that is alcohol against alcohol, it will not print a scatter plot. It doesn't make sense.
Yeah.
Then you get something like this. So instead, here is a histogram is distributed. So for every diagonal here, you see a histogram. And in this case, with color indicating qualities. Actually, this is not a histogram, it's a density kernel, which is a probability, but let's say it resembles a histogram-like picture.
Kernel?
Yeah, density kernel.
So then
It's probability.
the axis can be ignored then.
No, this is very interesting.
The graph itself, the axis then display.
This one, you mean?
Yeah.
Well, it will indicate, okay, what value, it's not printed here, it's printed here in can you see it?
The left axis.
So, this is the same axis as here,
But the height is basically.
and same here.
The value of the height is not so important, right? Or-
No, the height is not so important in this
That's
case,
what
no.
you mean.
Yeah.
It's more like an indication. It's a probability in this case, so.
So then it's like the surface of the graph should be something like 1 or.
Right.
Okay.
That's it.
Yeah, that's it. Okay.
So if you add it up.
Yeah.
The,
So it's the density indeed.
it's a density. Yeah. I think if you would fill it, then it will get to 1, right?
Yeah. Okay. So it's like a histogram, but it's really the density. Yeah. Okay. I understand. Yeah.
Yeah. Okay. So yeah, so this is again important because this will give you first indications on data by looking at these pictures and having some indications, and it will maybe also give you some hints. Okay, is my data good enough, or should I expand my data? Should I try to find other data as well? Should I make my data more complete or whatever? Yeah.
We got now 3 proposals in the email I saw.
Oh, okay.
Do you want to discuss it here
Yeah.
now, or do you
Yeah.
want to do it later?
No, I think we have time for it now. But let's finish off this one. So again, here you get.
Send it to your email?
Yeah, both.
Yeah. So again, to finish off this part, here again you see the things that you can easily do with appendix commands. I'll already put them on Canvas, so you can import them yourself and then try to run it. There's always good things to do to know what's going on, explore the data, make histograms, correlations, scatter plot by looking at the different features, and maybe other visualizations. For your group report, it's important to have these graphs included and make some good conclusions. And we don't want to see these types of graphs, right? Rather blow them up, show them very clearly what you have found. That's important. And don't put all the graphs in the appendix, but put them in your text, because then we need to go back and forth all of the time. It doesn't make your storytelling more clear. So if you want to have a good storytelling, put them in your story, how you examined and explored the data and what your conclusions are from this part, right? So this is the first part to do. The next thing, and I think I have, yeah, this one. So again, we have been using this CRISP, the cross-reference standard process for data mining. And this is also the different steps that you should use with the group assignment. And in these first 2 weeks now, we have more or less talked about these issues. So important always is, okay, what is the thing that you want to do? Look at the business, try to understand the business. Get your data, collect it, describe it. That means, making your histograms, making your overviews. Clean it, maybe put in some missing data and so on. And integrate it, like the example with the movies. It is not possible to have lists of actors or stars into your data frame. So take the stars separately, do a scoring on your stars and put the highest score, or make 2 or 3 columns with the 3 actors that have the highest score for a movie and put them into your final data frame, for example. That is about integrating data, right? So these are the steps. So for next week and the weeks following it, we start with the modeling. That means we assume that the data is there, the data is cleaned, you have your data frame, you have your labels there, so you have your, let's say, your target there, so that the modeling can take place with supervised learning mainly. Yeah. So starting from next week, we'll start with this one, and that will take most of our time here to go through all of the different algorithms and models and so on. Okay? Any questions so far?
What is the homework for next week?
The homework for next week is this. So again, read about the things that we've done in this first 2 weeks. Understand what the difference is between supervised and unsupervised. You've already did some things with Web Scraper. Read this book, Data Science from Scratch, it means, right? That's a book. So this is more background information, so just read it through and check it out. Things about statistic probability that might come in handy when you want to know, okay, how much data should I have? Is this enough, for example, right? And then again, I can recommend and do it. This one, hands-on machine learning, chapters 1 and 2. And follow it and type in your GoToColab, read chapter 2 and try to rebuild it yourself. And chapter 2 will actually go through all of the different steps. You have some idea already what's going to happen in the next few weeks. Okay?
Yeah, I try to create like a data set which you can use.
Right.
In the book. But when I tried to open it, it was not like it was like a corrupted file or something.
Okay. Did you get it from the Git environment? Because there is a Git environment from the writer.
I don't know.
The GitHub?
Yeah.
Well, isn't that the link that's also in the book?
No, you can find it yourself as well on GitHub.
Yeah, but I thought the link already took you.
Yeah. Probably the link will be referenced here as well, I guess.
Yeah, but the data set wasn't there.
Wasn't there? No. Okay. The housing data set it is?
Yeah.
Okay. In that case, let me check if I can find that file for you. Might be that I had a copy somewhere. And otherwise, yeah, let me try to find a copy. Yeah. Then you can follow, otherwise it will be hard to follow.
Yeah.
Yeah? Okay, good. So the homework is to read it, to do this second chapter, and you I think it's already on it. So hypothesis, inference is something as background information to read, to look at. And again, starting from Monday, Bart will start with regression as a first candidate for classification. Sorry, classification. So predicting classes. This is what we are doing here with the WineSet. Predicting a class. Is it class 3, 4, 5, 6, 7, or 8, right? So we have 5 different types of outcomes. Good. Yeah. The group assignments. We haven't read. I understood there are 3 proposals already there. So we can read them. We can discuss them right now. We have some time left. What is important for you guys to understand also is, okay, try to frame your problem also.
think
What
I
is it?
found the data set
You did?
of the
Yeah, the housing set,
I think
California
so. I'll
housing
put
set.
it in.
Yeah, put it on Canvas. Yeah.
No, I'm just gonna put it in Teams.
All right.
It's,
Okay. So try to understand. Okay, what kind of problem is this? Obviously, in the end, we want to do supervised learning. So that's a labeled set, like in this case, wines with a quality indication. But you might want to use unsupervised as well. If you have data which is not labeled yet, you can try to label it yourself, either by hand, but that will take too much time, but also by, for example, clustering. And then you can use unsupervised learning to find patterns and to attach labels to it and use that for your supervised learning. And most importantly, okay, is your problem, is it a classification problem or is it a typical regression problem? Because most machine learning, we start with the, let's say, the basic algorithms, and then you can either choose between predicting a class. Is this a cat or is it a dog, for example? Or predicting a number, like this one. Can we predict the car price of a second-hand car? That will be somewhere on a line of values. So we're predicting a value instead. Yeah? And I would like to recommend that you try both in your, for example, the wines, we can also, let's say, try to predict a value in between these qualities. Don't necessarily have to be either 3, 4, 5, or 6, or we can try to predict, let's say, a linear quality like 6.5 or 6.6 for a certain line, for example. So try to use both in your group assignment. Making classes, for example, if a team wins or loses or plays draw, those are classes. You can predict a class. You can also predict maybe numbers, which is the first, let's say, the winner of the competition or whatever. Number 1, 2, 3, 4, etc. Okay. Well, we have some minutes left. Is there somebody that would like to bring forward their ideas? Maybe some, yeah?
We had a couple of ideas. We also sent it by email.
Yeah, we'll have a look at it anyway. But
okay.